Hello everyone, and welcome to the first module of this course. In this module, the first topic that we're going to be talking about is random experiments and events. And we're going to be learning about concepts such as randomness, probability, and we're going to look at definitions of random experiments, sample spaces, and events, and the relationship that exists between them, such as unions, intersections, mutual exclusiveness, and complements. We also will learn about the basic rules of probability, and you can see the discussions on all of these topics in the textbook, the Montgomery Applied Statistics and Probability book, and sections 2.1 all the way to 2.4. From a general perspective, in this course, we can divide the course to two pieces of probability modeling and statistical analysis. And we're going to be starting with probability modeling first. The first question that might come to your mind is, why do we need to study probability? Well, as engineers, we design, analyze, and improve systems, and an inherent feature of all of those systems is randomness. So we will have to deal with randomness in our design, in our modeling, and in this section of the course, we will learn about how to quantify randomness. How can we figure out randomness and incorporate it into our modeling? What is randomness? Let's start with the definition of randomness. And I want you to pause the video and think about synonyms of randomness that come to your mind and any definition that you can come up with for randomness. When you think about synonyms of randomness, uncertainty, unknown, chance, things like that come to your mind, which somehow define randomness. And classic definition of randomness is the quality of lacking any predictable order. So it seems like when we're lacking predictability and certainty in any system, we tend to call it randomness because we cannot see any predictable and certain order in that system. But another question is, why does randomness exist? Well, it could be that it's our inability to observe or understand the pattern. There might be a pattern there, but we just, as humans, we don't understand it, so we call it random. Or it can be just an inherent feature of the universe, or it could be both in some situations. What is a probability? Well, probability is the way that we deal with randomness. So when randomness exists, we tend to measure that with probability. So we want to quantify this concept of randomness in a way that we can incorporate it into our mathematical modeling and our engineering design. It's also a degree of belief, and it's a limiting value of the proportion of times the outcome occurs as the number of repetitions goes to infinity. So let me explain this one with an example to you. When I ask you what is the probability of obtaining tails when you toss a coin, you probably tell me it's 50%. Why do you say it's 50%? Because if you repeat tossing a coin, random experiment, so many times, about half of the time you realize that you obtain tails. That's why you say it's 50%. And that 50% is the proportion of times that you obtain tails. So you can think of probability that way as well. If you repeat that random experiment, the proportion of times that you get that specific outcome, it's the probability of that outcome. What is the use of probability as engineers? Well, we construct mathematical models for the most part to model the system behavior and to design systems. And we use these models to predict the future behavior of these systems. In fact, a great deal of what data scientists do these days, you might have heard of this concept of data science, and what data scientists do is predictive modeling. And the fundamentals of predictive modeling is probability and randomness. So we're going to be starting from a very fundamental point of predictive modeling. the topics and discussions that we're going to start with and define them, because these are some terminologies that we will be referring to them in the first half of the course. So we will start by defining them and giving you examples. Topics and discussions such as random experiment, sample space, event, Venn diagram as a tool, union of multiple events, intersection of multiple events, mutually exclusive events, complement of an event, and eventually probability, where it is a way of quantifying randomness. So in the next video, we're going to start from random experiment and talk about these topics.